After a mission that took 25 years and cost about $10 billion, the James Webb Space Telescope has finally left the planet. Webb's mirror is 6 times bigger, and its instruments are set up to see longer wavelengths so that it can find the stretched out light from early galaxies 13.5 billion light years away. Webb is meant to be the next big thing after the priceless and well-loved Hubble Space Telescope. The telescope was made in an unusual and hard way because its main goal was to look at the first stars and galaxies to form after the Big Bang. The Webb telescope is made to look a lot less like a shiny tube and more like a big honeycomb on a silver surfboard. In a nutshell, the answer as to why it looks like this is that it must be very big and very cold. The James Webb Space Telescope, which was made by NASA, the European Space Agency, and the Canadian Space Agency working together, is expected to be the most powerful space telescope ever made. What's the secret to its amazing ability to notice things? A big golden mirror. The main mirror is made up of 18 smaller mirrors that, when put together, will let mission teams use the scope to measure light coming from billions of light years away galaxies. At a press conference in May of this year, Lee Feinberg, who is in charge of the James Webb Space Telescope's Optical Telescope Element Manager, said, "What we really need is for all those 18 mirrors to work as if they're a single monolith." The Webb Space Telescope's main mirror is 6.5 meters or 21 feet 4 inches in diameter and is made up of 18 hexagonal mirror segments that are each 4.3 feet or 1.32 meters in diameter. Also, the secondary mirror of the Webb Space Telescope is only 2.4 feet or 0.7 meters wide. Because of this, the James Webb Space Telescope's main mirror will be a lot bigger than the Hubble Space Telescope's mirror, which has a diameter of 7.8 feet or 2.4 meters, bringing a huge hexagon into focus. The James Webb Space Telescope will eventually land in space at Lagrange Point 2, which is the point in space that's directly behind the Earth when seen from the Sun's point of view. There, the device will get accurate measurements of faraway celestial bodies. The telescope's infrared view will be able to see through the dust between the stars. The picture was made by Northrop Grumman. NASA said in a statement that the honeycomb mirror segments of the Space Telescope are made to fit together so that the primary mirror, which is made up of all the pieces, will have a shape that is roughly circular. This information comes from how the honeycomb-shaped mirror segments of the Space Telescope were made. A roughly circular shape for the mirror as a whole is what we wanted because it concentrates light in the smallest area on the detector, says the statement. If the segments were circular, there would be gaps between them, but if the pieces were round, there wouldn't be any space between them. For example, pictures made with an oval mirror would be stretched in one direction. A square mirror would take a lot of light away from the point where it should be. In addition to being made in a way that lets it gather light from very far away, Webb's mirror works with the help of mechanical parts called actuators. Actuators are small mechanical mirrors that help the mirror focus on things that are far away. By using the 6 actuators on the back of each mirror, the mission team can fine-tune Webb's view. These actuators can move each piece of the mirror very slowly and in very small steps. Feinberg says these actuators are actually a pretty amazing piece of engineering because they can move long strokes, which are called core stage, and they also have a fine stage that can move very precise fractions of a wavelength of light. These actuators can move long strokes, which is called the core stage. They also have a fine stage that can move fractions of a wavelength of light with great accuracy. Why does it look like gold? The James Webb Space Telescope has a main mirror that's 21.3 feet or 6.5 meters in diameter. Aside from the fact that it's huge and has a hexagonal shape, the thing that stands out the most about Webb is that its mirror is a shiny gold metallic color. Because of how interesting the Space Telescope looks, NASA even held an art contest and asked people from the general public to send in pieces of art that were inspired by it. So why use gold? Feinberg said, "It has a lot of qualities that make you think, which is readily apparent in its brilliant appearance. It has this amazing ability to reflect light. In fact, gold has the highest reflectivity over a very wide range of wavelengths," said the scientist who found this property. He went on to say, "The reason you build a telescope that big is so that you can catch every single photon. So you need to make sure that each of these coatings has a very high reflectivity so that we don't lose any photons along the way. Webb's mirrors are said to have a reflectance of 98%, which means that 98% of the photons that are sent toward them are reflected back. This is the most reflective that something can be. Feinberg added, it's also a protective gold that has an outer layer. It has a very strong layer. Now, even though Webb's mirror pieces are covered in gold, they are not made of solid gold. In reality, they're made of a metal called beryllium, which is very light but very strong. On our planet, each piece of mirror weighs about 20 pounds or 46 pounds. NASA said that the beryllium can keep its shape even in the very cold temperatures that Webb will need to work. This is on top of the fact that beryllium is very strong even though it's relatively light, putting together something greatly cold. At NASA's Marshall Space Flight Center, the James Webb Space Telescope's mirror is tested in a cold environment. Webb has been in the works for more than 20 years since work on the scope started in 1996. Bill Ox, the project manager for the James Webb Space Telescope, said at the same news conference that Webb's mirrors had to be designed, made, and tested by a product integrity team made up of optical experts from all over the world. Ox said that the team tested the equipment at NASA's Johnson Space Center in their chamber, which was built during the Apollo era and has since been updated to become the world's largest cryogenic chamber. We were able to set up the whole telescope in this cryogenic chamber, which Ox said is a place that uses very low temperatures to make a very cold environment. Webb's observations use infrared light, which lets it look into the most faraway parts of the universe and find galaxies and stars there. Since infrared light is mostly heat, Webb wouldn't be able to see infrared light beyond the brightness of its own mirror if it got too hot. In fact, Webb's mirrors won't work right unless they're cooled to about negative 364 degrees Fahrenheit or minus 220 degrees Celsius. So that the temperature stays so low, the telescope will be sent into deep space, where it will use sunshades to protect its mirrors and other instruments from any leftover heat from the sun. By putting Webb's priceless mirror pieces through these tests, the team was able to make sure that they would still work in such cold and harsh conditions. Thanks for watching this video. Stay tuned for more.